All right, this is lesson 79, metric volume. All right, so you just have a few more measurements that now you need to memorize, right? How do we convert centimeters to inches? What's the conversion? 2.54 centimeters is 1 inch, okay? What about centimeters to meters? How many centimeters in a meter? 100. How many meters in a kilometer? 1,000. How many feet in a mile? 5,280. Okay? Now you have new measurements to memorize, okay? All right. 1 liter is equal to 1,000 centimeters cubed. Okay? So you just write these down. And 1 centimeter cubed is 1 milliliter. So look at this. 1 liter equals how many milliliters? 1,000. 1,000 milliliters, right? All right. So look at 79.1 on page 328. It says use unit multipliers to convert 14,000 milliliters. We're going to go from 14,000 milliliters to liters. We want to go to liters. All right? So, what do I use to convert 14,000 milliliters to liters? I take my 14,000, oh, this one writes nicely, huh? Times, I want milliliters in the denominator. All right, so what do I want in the numerator?
1 liter.
I want liters, and I have the conversion. 1 liter is 1,000 milliliters, right? My milliliters cancel, so it's 14,000 divided by 1,000 liters. It's 14 liters, right? 14 over 1, right? Look at 79.2 on that same page. I'll leave my conversions up. All right, it says use unit multipliers to convert 4 cubic feet. So we have 4 feet cubed, right? And we want to go to liters. We want to go to liters. All right? So, what's my first thing I need to do? I want to go to inches, then to centimeters, right? So to convert this to inches, I must have feet in the denominator, inches, and there have to be 3 of them because it's cubed, right? Say yes, yes. All right, thank you. 12 inches in a foot, cubed. That's 4 times 12 times 12 times 12 so far, okay? Now we're going to go from where? Inches to centimeters, because it wants us to go to liters, right? Okay, so we're going to go inches to centimeters, and it's going to be cubed, right? And there's 1 inch in 2.54 centimeters. Now we want to go to liters. All right, so now what must I multiply by? I want liters in the numerator, and I can put my centimeters cubed, right? This one. So 1 liter is 1,000 centimeters cubed. I don't have to cube this one. Do you understand that? I don't. In the conversion, it's already cubed by centimeters. I did not say I wanted cubic liters. I just want liters. Okay, so it's going to be 4 times 12 times 12 times 12 times 2.54 times 2.54, all that over 1,000. I missed a 2. Yes, thank you, times 2.54. Thank you, Caleb. All right, does that make sense? Okay. Look at the second part of this lesson. Is 45, 45, 90 triangles. You guys know the 30, 60, 90 already. All right, this is very practical because if I have a square and I have a diagonal, the diagonal of the square cuts this into a 45, 45, 90 triangle, with the diagonal being the hypotenuse, leg, leg. Okay? Now, I'm going to use, just like I did with my 30, 60, 90, I used 1, square root of 3, 2, as similar numbers to calculate a missing value in the other triangle, right? I'm going to do the same thing. So 45, if we have one leg is 1, the other leg is 2, the hypotenuse is the square root of 2. Why? If I did the Pythagorean theorem, 1 squared plus 1 squared equals the hypotenuse squared. What's 1 squared? What's 1 squared? What's 1 plus 1? 2 is the hypotenuse squared. Take the square root. The hypotenuse is the square root of 2. Okay? It makes sense. All right, so look at 79.4. We have a 45, 45 triangle. We have X, Y, and 7. All right, so in this triangle, we have X, Y, and 7. In the similar triangle, we have a leg is 1, the other leg is 1, the hypotenuse is the square root of 2. I can use cross multiplication, can't I? Always choose the one that has both values and then one that has one variable. So I have y over 7 equals 1 over the square root of 2. I cross multiply. 1 times 7 is 7. Square root of 2 times y is the square root of 2y. Divide by the square root of 2 on both sides. And y is 7 over the square root of 2. Now you can rationalize that. Put it in your calculator. 7 over the square root of 2. It's going to be 7/2 square root of 2. Probably. 7 over the square root of 2. It's 7 times, right, because I would multiply by the square root of 2 over the square root of 2 to rationalize it. Square root of 2 times the square root of 2 is just 2. And that would have been 7 square root of 2.
No, what's wrong with 7 over the square root of 2?
We don't like radicals in the denominator. We like to rationalize our fractions.
Wow.
Yes, because, you know, we
We
like to make it, I have not typically taken points off for that. All right, any questions? These two lessons so far make sense? Good.